computer. Well, I hope everybody here had a good break. This week, basically what we're going to do, we're going to talk about the last topic to cover in this course. And then we are done with assignments and homeworks and projects. So the only thing left is the final exam. Today we are, as I said, we're going to cover the last topic in this class. And on Thursday, we are going to have a review about the final exam. I'm just going to give you an idea about the final exam. There will be two parts. One of them is going to be true and false questions. And then the other part is a programming question. Now, for the programming question, on Thursday, I'm going to answer a question very, very similar, little bit less complicated version, or as I will say, a very similar question that's that you will be seeing in the final exam. So next class is extremely important. So I'm going to video record it, of course, and I'm going to upload it. But watching that video or attending the class is going to be very, very important to be able to answer the program question, because basically we will be doing something that is related to object-oriented programming. But I thought about putting the question. Then when I looked at the answer and I saw the answer for that question, I was like, I need to give the students a good explanation about a situation very similar to the one that you're going to be facing in the final exam. So there will be no surprises. Okay, with that being said, let's talk about today's class. I'm trying my best to get the grades up to date, and I think I did a good job a little bit. There's only two homeworks maybe, and one project that's not graded yet. Probably by the end of this week, I'll get everything up to date. Okay, so let me start sharing my screen. And of course, if you have any question at any time, just let me know. We are going to talk about three topics today. We're going to talk about abstract. We're going to talk about interface. And we're going to talk about polymorphism. So we're going to talk about those three topics. And those three topics are all related to inheritance. So having a good idea about inheritance is extremely important to be able to understand the topics we're going to cover today. We're going to start with abstract classes, and then we're going to talk about interfaces. And then after that, we're going to talk about polymorphism. Now, before I say anything about those three topics, you should know that a lot of changes has happened to Java recently. So sometimes when you do a research and you read about Java, you will notice that some definitions will fit for certain versions of Java, and some definitions will not fit for a certain version of Java. And now we're going to talk about all of them, of course, as we go through the class. So first thing first, instead of me typing everything from scratch, which if I do, it will take forever, I decided to create everything and make it ready and just go for it. So here we have a project called Abstract Demo, and I'm just going to open that Abstract Demo. And I do have here 4 Java files. And I'm going to open them one by one, and I'm going to try to explain the concept of abstract. So let me just open this one. This is the main method. This is data analyzer, numerical data analyzer, and string data analyzer. Let's get back to the main method. Now, here's the deal. Let's just start with this. We talked about inheritance before, and we said inheritance, simply, you can create new classes using a class that has been already created. And we said the idea of inheritance is, instead of me repeating the same code in different classes, if all these classes have a common class that they all belong to, it will make more sense to create that superclass and let all these subclasses to inherit from that superclass. That was inheritance, and that was inheritance is all about. Now, so what is abstract? Abstract, technically, abstract is a class that simply starts with the keyword abstract. So let me just show you here. Here's it, abstract. So whenever you create a class, instead of just class, for example, data analyzer, you start with the keyword abstract. That will make it an abstract class. So that'll be number one. Number two, abstract classes sometimes have what we call abstract methods. Now, what is an abstract method? Well, here it is. Those are 3 abstract methods. You can see them here. An abstract method simply starts with the keyword abstract, just like how the class starts with the keyword abstract. And the abstract method doesn't have a body. As you can see here, for example, this constructor does have a body, but we have an abstract method here, we have an abstract method here, and we have an abstract method here. All these abstract methods, if you notice here, after the header of the method, you have a semicolon. You have a semicolon, semicolon. So those 3 are simply abstract methods. And how do I know an abstract method? Simply by, it has to start with a keyword abstract and it doesn't have a body. Okay, so that's the technical part. Let me finish the technical part and then I will talk about, so what's the point of that? Whenever a class inherent from an abstract method, that class, the subclass, must override all these abstract methods. So you can see here, this abstract method here that doesn't have a body, this abstract method doesn't have a body, and this abstract method doesn't have a body. When it was inherited by this class here, you can see that, where is it? If you go back here, you see that we have a method called calculate average, find max, and display results. And here it is, calculate average, find max, and display. Each one of those methods, we are overriding it from the abstract class, and we are actually implementing them here. Okay, so that's a must, by the way. Now, the question is, what if I do not implement those methods inside the subclass here? That simply means your subclass must be defined as an abstract class. Okay, so that's, again, rule number 3. And you will see here in the string data analysis, we have the same rules here. Data calculator, calculate average, find max, and display results. All these 3 methods, because we inherited from this abstract class, we have to implement them here. So those are the technical side. Again, what else do we need to know about abstract classes? Abstract classes, you are not allowed to create objects of abstract methods. Abstract classes. Like, you cannot come here, and let me just show you what do I mean by that. If you try it, it will not work. And notice this is a constructor, so I can actually do that. If I come here, Control V, and I will call it, for example, D1 equal new, and the constructor simply get an array, and that array, for example, let's just pass this one here to it, and Control V, and I have to wait a minute, take that away and put this here, and here we go. And you can notice here he's giving me an error message. If you put it here, cannot instantiate the type data analyzer. You cannot create an object of an abstract method. Of an abstract class. So those are the rules of abstract classes. Abstract classes, again, start with the keyword abstract, may or may not have abstract methods. An abstract method is a method that starts with the keyword abstract and doesn't have a body, and it's just a signature plus a semicolon. Any class that inherits from an abstract class must implement the abstract methods here. Otherwise, those classes are going to be considered as abstract classes, and you have to add the keyword abstract here.
So abstract classes exist so you could make subclasses out of that abstract class, but not to actually make a class out of it?
Yes, that's exactly the point. And I'll give you an idea.
So then what's up with the abstract methods then? Why do you need
I'll get to that point.
Okay.
So I'm just trying to collect all the questions. Does the abstract class need a constructor at all? Yes, it does, especially if you have a data type like defined inside the abstract class. For example, we have this array. And because we have this array, then yes, we have to assign it with a constructor. That's one of the questions. So let's go back to your question, Ahmad. You said the point of abstract classes to start with is that you should not be able to create objects of that class. And I'll give you an idea here, and you can apply it whenever you think about it. If it doesn't make sense to define an object based on a specific class, then you should have that class as an abstract class. For example, and I used that before, when we decided to talk about animals and we created subclasses, cats, dogs, elephants, and we inherited from the class animal. It again, if you just think about it this way, when somebody says, or when an object in a project is an animal, that doesn't make that much of sense. It's an animal, I understand, but what type of animal? So it makes more sense to create object of the subclasses, and it doesn't make sense to create a class of the superclass, because somehow it doesn't make that much of sense. The abstract classes have a private member variable. Okay, I'll get to that question in a sec. So that's the whole point with abstract classes, is that you don't want, the whole point here is that you want to have this class and you want to inherit, you want other classes to inherit from it, and you don't want actually to have objects created for that class. Now, I remember one of the question was, why do we need to have abstract methods? Well, having abstract methods, again, is optional. Not necessary that you must have abstract methods, but in general, the whole point is to inherit. The whole point is to inherit from that class. So you need to have some definitions here. And I'll give you an idea here, just to give you an idea. Those abstract methods, it's more like a sort of contract that if you're going to implement, if you're going to actually inherit from me, then you are forced to implement those methods. Does that make sense? Like, for example, if you're going to create a cat, then that cat must breathe, must move, what else? Must eat, must drink. So it's more like you're providing a list of actions and behaviors that the subclass must implement. How exactly is implemented? That's not the big deal, but it must do it.
So you have to have calculate average in every subclass of this object?
Exactly. That's the point here. So abstraction, again, in addition to what I said before, is that you are not allowed to create objects out of that class. Also, it's a way to have a to-do list and to pass it to those subclasses. So any class that's going to inherit from the superclass must implement those methods. Now, how is it exactly going to be implemented? That's up to you as a programmer. But it's a must. It's a must to happen. I'll give you an idea here, because this concept is very, very similar to interface that we're going to cover next. Interface, it's a form of abstraction. We're going to talk about it in a sec, but it's also a way to force classes that are going to inherit from it to implement some operations. I'll give you an idea so it will make more sense to you. Now, imagine you want to create a product. And let's say your product, let's say a network product, a device or protocol that is used by the internet. Now, for your product to be able to function and work with other products, there are certain functionalities that your product must be able to implement. How exactly is going to implement them? That's up to you. You're going to create a new product. You're the designer. You have to get it done. I don't care how you're going to get it done, but it must be done for your product to be compatible with other products. And that's the whole point of the abstract class. Not only that we are doing this because we don't want to create objects out of the superclass, but at the same time, we are trying to push some behavior to be implemented by the classes that are going to inherit from that abstract class. Let me see here. Does the abstract class need to have a constructor at all? Again, it depends. If you have data member here, then yes, it must. Does abstract class have a private member variables? Well, you can create a private, but remember he said, whenever you're going to start inheriting from a class, it's a good idea to define the data members as protected. So you will not have an issue with accessing to those data members from other classes. Are there any other questions about this before I continue? Okay, so let's look at the example that we have here. What do we have? We have a class called data analyzer. In this data analyzer, we have a protected data type of object data. Now you may ask, what is object? What is the data type object? Now the data type objects, and I'm going to show you that by an example. If you click on creating a new class, and let me share the screen here, because I want you to see this small window that you see here. Look at this piece here, superclass. Every time you create a class in Java, by default, you're going to inherit from a class by default called java.lang.object. Okay. Now, object by itself, it could be any data type. So, oh, wait a minute. Let me just go back to my. So when I said object, array of objects, and I'm calling it data, that simply means it could be any data type. Okay. Here's my constructor. And here are my three abstract methods, one of them to calculate the average, one of them to find the max, and one of them to display the results. Now, we do have two classes here. One of them is called numeric data analysis, and we have a string data analyzer, sorry, and both of them are extending from the data analyzer. If you look at the data analyzer, you can see here that we don't have any data types here, so you simply are utilizing this data type, and you are creating a public numerical data analyzer. And instead of objects, since this is about numerical, we decided to go with doubles. So it's going to receive a double of an array. And again, it's going to be passing it to the constructor of the superclass to be assigned to data. Okay, so that's, again, the constructor. Now let's go to the implementation. What am I trying to do here? I'm trying to find the average. So here's what I'm doing. I'm creating a sum, assign it to 0. And I'm having for each loop or smart loop, an object, value, data, and I'm doing the sum, and I'm casting the value, which is an object. So I'm treating it as a double, and I'm adding them up to the sum, and then I'm dividing sum divided by data.length, which simply how many items do I have in that data array, and that will give me the average, and that's what's going to be returned. Find the max. I created here a double, and I'm calling it a max, and here double.mini value. So this double.mini value simply is going to look for the minimum possible value that a double could have, and it will simply assign it to max. And then all I'm doing here, I'm going with this for loop for each member of that data array that I have, and I'm finding the max of the max value that I already assumed here with the current value. Now, of course, this could be implemented in a different way, but this is just one way to get the job done. So simply I'm comparing every single value with the max value that I assumed at the beginning with the minimum value with the current value in that array. Give me the max. And then I take that value and compare it to the second one and give me the max. And I compare the max with the third value and then give me the max, and continue that way until you're done. And then you return the max, which is simply going to tell me what is the maximum value that we have here. And of course, after that, we have the display. So I'm showing here the average, and I'm showing the max value by calling those two methods here. Now, for the strings, of course, the calculations are going to be different. The idea here is that to find the average, again, we have an array of strings. And what I'm going to do, I'm going to have an integer that will have the summation of all the lengths of the string. So if you're passing an array of 5 words, every single word will have a certain length, number of characters. So this will tell me, this will calculate string value. So I'm converting the value and then tell me the length, how many characters do I have? And this will give me how many characters do I have in the whole array of strings, and I'm dividing it by the number of elements in that array. And that will simply give me the average. Again, this is just how I defined the calculation of an average of strings. Summation of the number of characters divided by the number of strings. That's, again, you can calculate it in a different way, of course, if you choose to. This is, again, just an implementation. Now, to find the max, what we're going to do, we're going to look for the word with the longest, the longest string that we have in the array. And I'm going to assume that that long string is simply 0 at the beginning. And I'm going to go with a for loop, and I'm going to compare every single string in that array with the max length. And every time you find one that's longest, you're simply going to update the max length string. And then after that, you're going to return that string. And finally, after that, you will display the calculate average and the find max. Now, if we go to the data analysis, you will see that here I created a double. And look at this. I said numeric data analyzer, numeric analyzer equal numeric analyzer, and I'm passing the numeric analyzer. And here we go. I'm calling the display method, which is simply going to display all the information related to the numerical array that I have here. And here I'm passing this array of strings, and I'm creating string analyzer object, and I'm calling the results. And if you run it right now, you'll see that this is the average of the numeric analyzer. And this is the maximum value that we have here. And this is the average length. So if you just add all these characters together and divide it by 1, 2, 3, 4, 5, you'll get 5.4. And then the longest string here is JavaScript. And this is, again, what we mean by abstract. So if I want to summarize abstraction, I would say an abstract class, you will not be able to create objects out of it. Abstract class start with the keyword abstract. An abstract class could have abstract methods. Abstract methods, again, our methods are defined with the keyword abstract and the signature of the method, and ends with a semicolon with no body. The reason why we do have them is simply to force the classes that's going to inherit from the abstract class to implement those methods. And after all, if you inherit from an abstract class without implementing those abstract methods, your class is simply going to be treated as an abstract class, and you will be forced to add the keyword abstract here. Are there any questions before I move to polymorphism?
You mentioned something alongside abstraction. I don't remember what it was.
I mentioned what again?
You mentioned something alongside abstraction that you were talking about.
Interface, polymorphism.
Yeah, interface. That's
Yeah,
it.
I'm gonna get to that point.
Okay, I thought you talked about it already.
No, I have a different example for it.
Okay.
Yes. Okay, so before I go into the interface, polymorphism is somehow related to abstract classes. So I think it's a good idea to talk about that before we jump into the interface. And I do have it here, the example, which I'm going to actually talk about in a sec. But before I get to that point, let me explain what is polymorphism here. Now, polymorphism, it's a situation, by the way. Just because polymorphism does exist doesn't necessarily mean that you have to use it. But sometimes, depending on the application itself, you may actually need to use it. But let me just use an example here. Have you guys saw the movie It?
I saw the new one.
There too.
Yeah, I
Okay.
think I saw the new one.
Okay. So It, when somebody asks you, what is it? What do you see? What do you say? It by itself,
Like a horror
nobody
movie,
knows.
maybe?
Nobody knows what it is, but it's something that takes multiple shapes and multiple forms. Okay. The idea here, what I'm trying to say is that sometimes in object-oriented programming, you may have an object that acts in a different way depending on the different situation that this object is actually in. I'll give you an example. Let's just imagine there's a person. Okay. That person talk. That's an action. That's a behavior that that person can do. Now, that person talk to his kids, and that person talk to his boss. So you can see here, it's the same object. One time he talked like a father, and one time he talked like an employee. But after all, it's the same object that's performing the same action, but he's doing it differently depending on the situation that he is in. This is what we mean by polymorphism. It's the fact that you can have a single object that will perform the very same operation, but he will implement it differently depending on the situation that that person is actually in. And that's as simple as it could be described. That's what polymorphism is. And the word polymorphism simply means multiple forms. Okay? So how is that possible? How can I get to that point? The idea is very, very simple. And I can show it to you here. But now, and I'm actually going to be doing it. Let me copy this. And let me put it here. Control V. And let me take those comments away. Okay. Let's see here. Why is he complaining about this? Oh, yeah. This is not right because we said we are not allowed to do that. Okay. Now I want you to pay attention to what I just did here. I said, look at this, data analyzer. Now, what did I say about data analyzer at the beginning? I said it's an abstract class, right? So I'm not supposed to be able to create an object of the data analyzer. And that is, to this point, is correct. But look, what do I have here? Equal new numeric data analyzer, and I'm passing an array of doubles. Okay, so this is totally acceptable when you have an abstract class and you have another class that inherent from the abstract class. What you can do, you can start by creating the object of the data analyzer D, but the content of that class is simply an object that belongs to the subclass, numeric data analyzer. So I want you to focus on D. If you look at D, okay, despite what you see here, if you look at D, what would you classify D as? It's a data analyzer object, okay? And yet, when I said display results of D, he's simply going to show me exactly the same result that you see here. Now let me move down. Look what I just did here. D equal new string analyzer, and I'm passing string data to it. And then I said D display results. And if I just come here, and let me comment this part, and this part, and this part, and this part. Let's talk about polymorphism at this point. An object D that has a method called display results. And if you look here, yes, here's display results. And here's the data analyzer. And is going to show me and it's going to display the results of a numerical array. Why? Because of the content of the object is numeric data analyzer. And look what I did here. This is where I'm shape shifting. Now I'm moving from being a numerical data analyzer object as a content to a string data analyzer content, and then show me and display the results. And if I run it, you will get the exact same results without the extra space that I have here. So let me just
you make an object from the superclass
from the abstract class, yes.
Yeah, and then you can switch it between subclasses.
Subclasses, exactly.
Is that only if the superclass is an abstract class?
Not necessary, but usually it's like if I'll just show you that this is not necessary. You can get the same result if this is not an abstract class, but usually we apply it. It's applied in a situation like this.
Like if we had an animal object, we could make it go from
it will work.
Okay.
But again, if you think about it again, go back to the whole point of why is it not a good idea to create an animal object? Because that object in reality doesn't exist. You cannot tell someone this is an animal and that person will be okay and accept that from you. Because if you say an animal, okay, what type of animal?
So it's still like a base animal object, but you're switching its data. Okay.
Yes. I'll give you an idea just so you will have. Imagine that you get a call from your home and somebody's telling you, we have an animal in the house. What will be your first question? What type of animal? Right? But if somebody tell you, we have a cat in the house, we have a dog in the house, do you really need to ask about what type of cat or what type of dog? You have an idea. So this is, again, the same thing. If the existing reality of the existence of that superclass doesn't make that much of sense, it's a type of abstract, then you have to go create an abstract. But the idea here, again, yes, you can actually achieve the same results without having abstract classes. Like, for example, if I just come here, and I'm going to show you that, if I take this one away, and I take this one away and just put return 0, and if I take this one away and I say return, let me try to remember here. What do we return if it's object? Null? No, he doesn't like it. Object, what's the default value for an object? Return 0? No, he doesn't like it. Well, I need to take this abstract keyword away. And I need to take this abstract keyword away. And now it's acceptable, okay. And I need to take this one away. So now you can see that it's not an abstract class anymore. And this will not get affected. So yes, you can apply the concept of polymorphism, whether it's an abstract class or not abstract class, but usually it's applied to abstract classes. So go back to our abstract class. And here we go. So this is polymorphism. Now, let me just again highlight the whole point. Object D calling display results and is going to show you display results. Okay. Object D, the same method, different results. Just like how I said, a person talking like a father the same person talking like an employee. Do you see the idea here? That's what polymorphism is. Now, again, those techniques, just because they do exist, that doesn't necessarily mean that you have to use them whenever you create an object. It's simply a design decision. And if you have an object and you know that you're creating, whatever you're creating, and you know that simple object will change its behavior depending on the situation that that object is in, then yes, you have to create it in this form. You have to utilize polymorphism. So at this point, I believe that I covered abstract classes and polymorphism. Are there any questions about these two topics? And I'll be honest with you guys, those used to be one of the topics I remember when I was a student. They were like very confusing when I heard about them the first time. But believe me, they're not that complicated. They're really, really not that complicated. They're easy, simple. Just have the knowledge of the basic techniques of how to use them and just understand what is the point of abstract classes. And as I said, I will say two main points of abstract classes. Number one is to, again, you don't want to create objects that belong to the superclass. That doesn't make that much of sense because it's a type of abstract, and abstract objects do not exist in reality. So that would be number one. Number two, it's a way that you can, in a form of signing a contract between the superclass and those subclasses. Like if you're going to inherit from me, then by law, you have to implement those methods. And again, we have them as abstract classes because we really don't care about any general implementation for them. We just want them to be implemented in those subclasses, especially that we know that we are not creating objects out of this class to start with. Okay, so are we okay to move on to our next example? If you have any questions, let me know. I'm gonna. What is that?
How much abstraction and inheritance is going to be on the exam?
Oh, the exam is going to be about interfaces more than abstractions.
Okay.
When I'm going to explain interface and I'm going to explain the question on Thursday, you'll have a really good idea. So you really don't need to worry about it right now. Okay, so let me close all these windows. And let's move to interface. There's interface demo. And let's open all these classes. Now, what is an interface? Well, interface is very, very similar to an abstract class with few differences. Let's see here. This is the main method. This is the class shape. Oh, here it is. So here's the interface. Interface simply, and this is, let me just tell you, this is the old definition of interface. Interface usually it's like a class that only contains abstract classes and constants. That's the old definition of interfaces, okay? But a lot has been changed ever since that. Interfaces, again, will have something called, now these days they have something called default methods. They can have static methods. They can have constant values. And that's what changed recently. So let me just go back to interfaces before and after. We have, before Java 8, interfaces usually can contain only constants and can only contain abstract methods. But recently, that all changed. And we can have what we call default methods. We're going to talk about it. We can have static methods inside it. Now, let me just talk about interface. What makes an interface different? Number one, when you create the interface by itself, if you go to the folder in your project and you click on new, and let me just see, I don't know if you can see this, but there's an option called interface. And when you click on it, you will be able to see a window like the one you see here. So this is not a class anymore, it's an interface. So that'll be number one. Let me go back to Java here, and let me close this. What is an interface? Interface, it's a way that we can overcome a problem we have with abstract classes and with regular classes. With regular classes, you can only inherit from one class. But with interfaces, you can inherit from multiple interfaces. So that's the big difference here. Difference number one, remember here, previously when we talked about inheritance, I don't remember if I said it or not, but you are only allowed to inherit from one class or one abstract class. With interfaces, you can inherit from multiple interfaces. So that's one way to think about it. Number one, interface could have abstract methods, and you don't need to use the keyword abstract. Because by default, if a method, it's not a default method, or it's not a static method, then it's going to be an abstract method, and you must implement it in your subclass. So in the example that you see here, calculate the area, this is considered an abstract method. And if you're going to inherit from this interface, you have to implement this method, just like how we had with the abstract class. Now we can have constant, and even though this is a constant, you really don't have to use the word final, because by default, if you create any variable, it's going to be considered as a constant. And you can extend it, you can use it here with no problems. Default methods, again, those usually are methods that's going to be inherited, it's going to be implemented, as you can see it here. Think about it as a regular method, but you have to use the word default, because otherwise, if you take the keyword default, is going to be considered as an abstract, and if it's going to be considered as an abstract, then there should be no body. So if you have a method, yes.
So why does the interface's default methods still do something if they're not intended to actually be
it's going to be implemented inside the inherited class as a part of that class.
The inherited classes will override the display info, right?
Not necessary.
Okay.
Yeah, not necessary.
Okay.
If you want to override it, you can do it, but if you want to keep it, you can keep it as well.
Okay.
Yes.
Okay.
And a static method, it's a method that you call by the name of the interface itself. So it's related to the interface itself, that you can have access to it from your main method. Where is it? Your main method here. Okay. So let's go back to, where is it? Shape. So this is the interface. This is the abstract method. This is a constant. And this is a default method, and this is a static method. This is, again, just a demo to explain the concept. Now, as I said, starting from Java 8, those default method has been added. Before that, like when I was a student, there were no default methods. When I was a student, there was no static method. You were not allowed to have static method. When I was a student, you were not able to have constant inside interfaces. So there's a lot of changes that happen to interfaces in Java 8. Now, let's talk about the point. What is the point of interfaces? As I said, number one, you can inherit from multiple interfaces. So that will be one of the keys here. One of the most important features that interface actually provide, and in reality, in the future, I'm pretty sure you will take a class called software engineering. In the software engineering classes, you're probably going to learn about something called pattern design and pattern design analysis. You would notice in that class that abstract classes are not used that much, but instead interfaces are used a lot more. And one of the most important features that interface provide is it's less coupling. Okay, Now you may ask, what does coupling simply means? Coupling simply means, and I'm just going to go back to regular classes and abstract classes. Sometimes when you have a relationship between multiple classes, if you update one of the classes and there's a relationship between that class and another class, that change that you apply to one class may reflect, may have some effect on the other class. And that simply means that you have to go and visit that class and see how the change that you applied to a certain class may or may not affect other classes. Let me just put that again slowly. When you inherit from a class, or for you inherit from a subclass, superclass, sorry, that's a regular, not abstract. Sometimes updating, let's say, updating the superclass may require that you go to all the subclasses and update them as well. That's a case in abstract classes or regular classes. But with interfaces, we make a disconnection between that.
When
So,
you say
what's that?
when you say update, do you mean like update the code or update a static variable?
Anything, changing anything about the class.
Okay.
Okay. And again, it may require, may not require, but in general, updating any class and you have certain relationships between those classes may again require that you go and revisit all the other classes and see if the change that you applied into the superclass may have any effect on the other subclasses. With interfaces, you don't have that problem. So you're making your classes more independent from each other. Why is that important? Because again, if you have projects with hundreds of files and classes, you really don't want to have that connection between all these classes, because if you think about it that way, making a simple change in one class may require you to go and visit all the other classes, and that will be a lot of work. But again, with interfaces, you don't have that connection. Any change that you may apply here, again, may not affect on those, except if you add, again, if you add a new abstract method here, then yes, you have to go and change it. But for example, if you change anything about this display info or anything about the static method, or you just added another constant here, basically you may never need to go and change anything about those classes that's going to implement that interface. And when I say not, I'm not saying always, but it's less. Interfaces, basically, when you utilize them and use them, makes all these classes less depending on each other. Let's just put it that way. Now, let's get back to the implementation of interfaces. So first of all, we don't have class anymore. It's called interface. Any abstract method, by default, you don't have to use the keyword abstract. So here it is. This is an abstract method. You can have constant, and you don't even have to use the keyword final here. It's going to be known as a constant. You're not allowed to change the value here. You can have default values, again, a default method, sorry. A default method is a method that has a body, a regular method. And when you inherit it by a subclass, again, you will have access to it and you can use it as you want. You can override it if you choose to. But again, for the abstract methods, you have to implement them. And we can have static methods. Simply, you can have access to the static method by the keyword interface, whatever the interface called, plus dot method, and that will simply call it. Okay, so those are the rules. Now, when it comes to how do we implement it? Now, when you inherit from a class or abstract class, we used to use the keyword extends. But when you inherit from an interface, we use the keyword implements. And if you want to inherit from multiple interfaces, use a comma and you type the name of the other interface. So you can extends one class and you can implement multiple interfaces. And usually whenever you want to extend and implement at the same time, you start by extending the class you want to inherit, and then you implement the interfaces. So what do we have here? We have a shape interface, and we have a square here, and we have a circle. Square and circles are inheriting from the interface shape. So let's go and look at the circle. So class circle implements shape. And what do we have here? We have a radius variable. And here it is. This is my constructor. And by the way, the interfaces, they don't need constructors, of course. So here it is. This is the radius, sorry. So this is the circle. And now here is me. I'm overriding the method of calculate area. And look at this pi. And pi is defined inside the shape as a constant, so I can have access to it. And radius multiplied by radius, this is going to calculate the area and return it. And display information, again, I decided that I'm going to override it here anyway. So it's going to display the information that I chose here. This dot calculate area. So it's going to calculate the area and show it to me. Now look at the square. Square has a side. This is, again, the constructor. I'm overriding the area, which is, again, side multiplied by side. And here it is of display info overriding it as well. So we utilized all these and we didn't use this at all here. So let's go back to the demo. And here it is. Look at this circle, object circle, and passing 5, square, 4, passing it, and then circle display information, square display information, and here we go. Now let's look at this example here to show you how do we utilize this method here, create a default shape. Okay. What do we do here? If you go back to the interface, I said shape, default shape equals shape dot create a default shape. Okay. Now let's see here. Am I missing a class here?
Where does the create default shape method come from?
Let me see here. Default shape. Oh, it's here. It's covered by this this zoom thing. Let me just see if I can move it away from here. Okay, I'm just going to try to push it down. Okay, here it is. Let's go back here. Where's the shape? So look at the shape class here. Static, shape, create default shape. So usually, again, as I said, whenever you want to have access to a static method, you start by typing the name of the class or the interface. And this is what I'm doing here. Let's look here back again. Shape default shape equals shape dot create interface shape. So I'm calling the method create shape. What do I have here? Return a new default shape. So this is your question. Where's this default shape coming from? Here it is. Default shape class, implementing shape, and I'm overriding the calculate area here just to returning 0. Because again, after all, there's no definitions of what is this default shape is. I'm just, again, assuming that the area is going to be 0. So if I go back here, where is the demo? And I said the area of the default shape is simply the default shape object dot calculate area, which is going to return 0. And here's the display information. Now this part here, again, is just a demo. This doesn't make that much of sense. But I'm just showing you that you can have a static method inside an interface, and that static method that just happened here to return an object of the interface shape. And again, it's the object itself, because just like how we did with the abstract, just because the default shape is inheriting from the shape objects, then yes, you can actually assign a default shape to an interface here. In another word, let me just show you what do I mean by that. I can say shape, let's call it C equal new circle and I'll pass here, let's say 15. Well, he didn't like it. Let's see here. Create a class called shape. Oh, yep, there's E. And do I have C here? No. Yep, just because I didn't use it. And now if I go here and say C dot display info, if I run it, let's just run it, give it a try. And here it is. So again, just like the part that you see here is very similar to what I just did here. Just because, again, let's just put it back away. The default shape, because it's inheriting from shape, then yes, you can assign an object of a default shape to the shaped interface. And that's what's going on here. Because again, the created default shape is returning an object of default shape, and this is the default shape. By default, there's no constructor here, and we're just overriding the method of calculate area. So when we call it, we were able to implement it, default calculate area, and display information. This is, again, what interface is all about. So interface, just like how abstract classes, it's a way to force the classes that are going to inherit from to implement methods. Now, this part that I'm talking about here is the most important part about interfaces and about abstract classes. It's, again, a method or a way that we can force other classes to act and to perform some actions. It's more like you're providing a new class a to-do list. This is a list of things that you have to do. You have to implement. I'll give you an idea here. Later, you may, I don't know if you're going to have a chance to do that or not, but you will notice that when you're going to learn about creating a graphical user interfaces, every time you create a new class, you have to implement some sort of interface. And that interface that you're going to implement is simply going to provide you with a list of operations that you have to implement for your graphical interface application to look and to work on an operating system. I hope this is not causing any complications and it's not complicated. And as I said, next class, when we're going to come, I'm going to go from scratch with an idea about how interfaces, again, interfaces and abstract classes are not that different. An abstract class is a regular class with the existence of abstract methods. That's the only difference here. But interfaces, again, interfaces, no, it's not a regular class. There is no data members. There are constants. There are default methods, and there are static methods, and there is abstract methods. In general, interfaces usually are filled with abstract methods. And it's a way, again, to force subclasses to behave in a certain way. And that's the whole point of interfaces. Are there any questions about this? I know it's a little bit more complicated than you may think it is, but believe me, it's really not that complicated. Just try to think about it as simple as possible. It is simple. It's not that complicated. It just, you need to have some sort of imagination to think about the relationships between all these classes and how do they interact with each other. And if you can have those rules in your mind and just understand them, then you should be good to go. Okay, I'm going to stop recording because I don't want this video to be very long.